Okay, so now we're going to look at solving quadratics by the square root property. So a moment ago we were doing factoring. Now we're going to look at some other methods of solving quadratics. Okay, so remember quadratics are when they have power of 2. Okay, so before we do that, we're going to review complex numbers. And so we're just going to do the basics on this. You could really spend quite a bit of time on complex numbers, but I'm really just going to kind of show you what you need to know. And what you need to know is when you square root a negative value, and well, in this case, -1, it will result in an I, okay? And so those are known as imaginary numbers. Now, it doesn't mean like they're a figment of your imagination. They were just coined that from long ago. So they've been coined as imaginary numbers, and you could take a full course devoted on the complex number system. And so I'm just going to show you the basics right here. So if you were asked, what's the square root of -25? A lot of people say, oh, it's -5. And that would be incorrect, okay? Because what you're trying to do is when you square root a value, so for example, if you're looking for what's the square root of A, well, the answer to that is you're trying to figure out, we'll say that the answer, we'll say it's B, right? And so what that is you're looking for what value squared would equal the value inside the radical sign, the square root sign right there. So what you're trying to figure out is what to the power of 2 would equal that value inside. And so if you said -5, that'd be incorrect because negative times a negative would turn into a positive 25, so that wouldn't work there. And so that's where about, 500, a little over 500 years ago, they developed this complex number system to deal with this issue. And so if you're going to square root a negative number, what you want to do is first, what we're going to do is we're going to we basically say we're pulling out an I, we're factoring out an I, and then what happens is you can drop the negative from inside there. So now you just have square root of 25. Now what's going on is these two things are getting multiplied together, okay, just to be clear. And so now you can square root 25. That's not very difficult. That is just going to be a 5. So now we're left with I times 5. And if you leave it like that, that's okay, but typically it's going to look a little bit nicer if you write it like this, 5I. Okay? So don't really overthink these when you square root negative numbers. You're just going to pull out an I with it, okay? So if you look here on part B right here, we pull out that I, and then you're just left with square root of 5. Now, square root of 5 isn't a perfect square. If I were to square root that and use a calculator, it would be a decimal that would go on indefinitely, and so that's an irrational number. And sometimes we'll use those numbers, but for the most part, we're just going to leave it as a radical. And I would just leave it like this. Okay, now you might be like, well, wait a second, you put the I in the back over here. And you can put it in the back. It's just you kind of have to be careful because if you write square root of 5 and then I, you just got to make sure it's clear that it's not part of the square root. And so to avoid that, we typically just we leave the I part in front of the radical sign. So if you do it this way, it won't be incorrect. Just be careful to make sure that it's not part of the radical sign. Okay, let's look at C here. So once again, I'll pull out that I, and then I have square root of 48. Okay, so square root of 48, once again, that's irrational. But in this case, we can actually simplify this, okay? And so there's a property here. If you have the square root of A times B, you can actually break it up into the square root of A times the square root of B. And so what we're going to do here is we can break 48 into 16 times 3. So we're going to have I and then square root of 16 times 3. And then what I can do is I can break that radical up into two parts. And so let's see, I got a little room over here. So we'll have I square root of 16 and then times square root of 3. So I can go ahead and evaluate the square root of 16 now. That's just going to be 4. The square root of 16 is 4. And then to make it look a little bit nicer, I'm going to put the 4, then I'm going to put the I, and then don't forget about the square root of 3. Okay, so that's how I'm going to write it. I think that's the way it looks the nicest. Okay, so just kind of a little review with the negative. I pulled that out as an I. then I broke 48 apart into 16 and 3, square root of 16 because it's a perfect square, and then that gave me a 4, 4i square root of 3. Okay, part D, pretty similar to what we just did on part C. So we'll start by pulling out the I, and then I'm kind of running out of room, so I'm going to do this in, I'm going to skip a step here and go ahead and start breaking this up. So 150, I bet that, let's see, our perfect square, I could break that up into 25, and I believe that would be 6. Okay, and so then the square root of 25 is 5. Okay, and then I have my I, and then I have square root of 6. And there we go. That's my answer for part D. And so you might be like, well, what about 6? I can break that up into 2 and 3. The only thing is you can't, 2 and 3 are not your perfect squares. So just a quick review. Your perfect squares are 4, 9, 16, 25, 36, and so on. You should at least know those to probably 144. Okay, we're not going to get too crazy. We're not going to, typically we won't go into triple digits or anything like that. Okay, so now we are ready to start solving. So this has all just kind of been a review right here. Okay, so right here to solve each equation by the square root property, isolate the squared variable or quantity before applying the square root property. Okay, so what's the square root property? So the square root property right here is if you have x squared is equal to some value, we'll call it k, to some number, then what we can do is to nullify the power, the square power, you're basically going to square root both sides. Okay, a square root nullifies a square power. But what happens here is you actually have to look at it as being equal to square root of k, or it could be equal to the negative square root of k. Okay, so you have to look at your answers being positive and negative. A lot of times, instead of having to write the equation twice, we'll actually use this symbol right there, plus minus. Okay, so, and that's what I'll do. And so the main thing you need to realize here is that there's really two answers whenever we use that symbol right there, the plus minus. Okay. Um, so let me do a really simple one before we start working these problems. So like, for example, if we had x squared equal to 25, okay, and you're asked, okay, what makes what to the second power equals 25? And right away, you'd probably say 5, and that's correct. But also, negative 5 would be correct too. And so what you do is when you square root to nullify the square power, you have to put plus or minus with the square root of 25. So your answer actually is positive or negative 5 would work. Because if you were to plug in negative 5 squared is negative 5 times negative 5. So those double negatives would turn it to a positive 25. So you actually have two answers there. And we're going to get two answers on all of these. Okay? So that was just kind of a basic example. So back to our directions, it says that you need to isolate the variable or quantity. So the first couple, we just have the variable x squared that we're going to isolate. But as we move forward, you can see on number 21, you have a quantity. This is what I mean by quantity. You have x plus 2 squared. You have a quantity that's being squared. And so you have to make sure that that quantity is isolated. So sometimes we might have to make some adjustments. Okay, so on 15 to get started, oops, 15 to get started, I have to isolate the x squared, the variable right here. So I'm going to divide both sides by 3. And so that's going to give me x squared equals 9. And then now the square root property, basically this is what we're doing. We're square rooting both sides, but you have to put the plus minus there. That's what the property states. And so the square root nullifies the square power. So I have x equals, and I have plus or minus, and then the square root of 9 is 3. And that's our answer. And so when you're doing your homework, sometimes you can put in the plus minus symbol. Other times you might have to type in 3 comma and then a negative 3. And it doesn't matter which one goes first. You could put the negative 3 first. Okay, so there's two answers there, just to be clear. Our next example right here to get started, we'll go ahead and subtract 1 from both sides, so that will cancel out. So we'll have 5x squared equals, and then 51 minus 1, let's see, that'll be 50. And then we'll go ahead and divide by 5 on both sides. So I'm just trying to isolate my x squared. So 50 divided by 5 is 10. Okay. And then next, what we'll do is we'll go ahead and square root. I got to put that plus minus. So we're going to have x equals plus minus square root of 10. And once again, you can leave your answer like that, or you can write square root of 10, comma, negative square root of 10. And if you want to later on, you can go back and plug these in, and you'll see it will equal 51 if you were to plug in square root of 10 or negative square root of 10. If you plug in either one of those, square it, multiply by 5, and then add 1, it will equal 51 for both cases. Okay. All right, let's look at 19. So we'll start by adding 5 to both sides, so that cancels out. 2x squared equals negative 50. And then now we'll divide by 2. So we get x squared equals negative 25. Okay, so now we'll go ahead and apply our square root property. And what we're going to see here is kind of what we saw up above when we were reviewing complex numbers. We're going to have complex solutions here. So what we're going to have to do here is you still want to put your plus minus, but that negative will give you an I, and then the square root of 25 is 5. So I'm going to go ahead and just write it as 5i now. So 5i, there we go. So positive or negative 5i right there. Okay, so now we're going to start looking at squared quantities. So it's isolated, so you're ready to go. So you need to nullify the square power right here. So I'm going to square root here, but then I have to square root over here, and I got to put plus minus. So that's going to leave me with x plus 2 equals plus or minus 5. Okay, now we're going to start running into these a little bit more as we move forward in this section. And so what we're going to do here, there's a couple of different ways you can approach this, but I'm going to kind of show you uh, the way I would do it because we're going to get some of these that are a little bit more complex than this particular example. What I like to do, so there's two sides of the equation. What I'm going to do is I'm going to subtract 2 from both sides. And what I'm going to do is I'm going to wedge that minus 2 right in front of the plus or minus symbol right there, okay? So this cancels out here. So I'm going to have x equals, so I subtracted 2, so I'm going to put it as negative 2 right there. And then I still have the plus minus 5 right there. Okay, now I can actually go ahead and evaluate that looking at it both ways. I can look at it as a plus and I can look at it as minus. And so I want to go ahead and do that. So my answers are going to be negative 2 plus 5 or negative 2 minus 5. And we say or because either one works. Okay, and so negative 2 plus 5 is 3. And negative 2 minus 5 is negative 7. And those are your two answers. And if you were to go back up here, you would see that those would work. If you plug in a 3, 3 plus 2 is 5. 5 squared is 25. If you plug in a negative 7, you'd get negative 5. And then when you square it, it does become 25. So both of those answers are correct. All right. Let's go ahead and look at a couple more of these. All right, so this time we have x minus 4 squared, but it's getting multiplied by 3. That's not being squared, so that means that we need to isolate this by dividing both sides by 3. So we'll go ahead and start with that. So let's see, that'll leave us with x minus 4 squared equals 15 divided by 3 is 5. Then we'll go ahead and square root both sides. I have to put plus or minus, so we don't want to forget that. So now we'll have x minus 4 equals plus or minus square root of 5. So you want to look at the radical and always see, can I break that apart into a perfect square? And the answer is no. So I can't break it into the multiple of two numbers where one of them can be square rooted. Okay, but I do need to finish solving for x. So what I'm going to do, just like on the previous problem, I'm going to add 4 to both sides, and I'm going to wedge it right in front of that plus minus. So this cancels out there, and I'm left with x equals positive 4. You don't need to put the plus sign, just positive 4 plus or minus the square root of 5. Now this time I can't, on the previous problem I looked at it in both plus and minus and I was able to simplify. Here you won't be able to simplify, so you can just leave it like this. And when you're doing your homework, you can use that symbol in your toolbar if you want to, or if you want to, it's fine also if you want to go ahead and just write it out twice. So 4 plus square root of 5, 4 minus the square root of 5. Okay, and if you were to plug that in, it would actually it would equal 15. Okay, so if you want to play around with that later, you can. You would see that yes, indeed, it does equal 15 if you plug in either one of those. Okay, so our next one here, we'll go ahead and square root both sides. So I got to put the plus minus. So we're going to have x plus 3 equals plus minus, okay, so I've got negative 16, so I know I'll have an I, and 16 is a perfect square, so that would be 4, and then I'll tack on the I right there. And then, just like the last couple problems, what we'll do here is I'm going to subtract 3, and just kind of wedge it right there in front of the plus minus symbol. So x equals negative 3 plus or minus 4i. And there we go, that's my answer. And once again, if you want to, you can split it to show that it's two answers, or just leave it with that symbol right there if you'd like. Okay, I think I have just a few more examples for us to look at. And so just real quick, we're practicing the skill actually for the next section of notes. So we want to make sure we have this down because you're actually going to be using this for the next, our next section. Okay, so looking at 27, what we'll do here is we'll start by square rooting both sides, plus minus. So we have x minus 3 is equal to plus or minus, and so I do have a negative, it's a negative 5, so I am going to pull out the I, and then I'm left with square root of 5, which is not a perfect square, so I just have to leave it like that. Then what we'll do is we'll go ahead and add 3 to both sides. So I end up with x equals 3 plus minus I square root of 5. And I'm just going to start leaving it like that. Um, I have in the past sometimes where the computer actually forces me to type it out twice, so just be aware that sometimes you will possibly, it'll ask you to type it out twice. They're just trying to make sure you understand that we're really getting two answers here. Okay, but I'm going to start leaving them like that for shorthand. Okay, we got 2 left here. So let's see, let's look at 31. So yeah, my squared quantity is isolated, so I'll square root both sides. So I get 5x minus 1 equals plus or minus the square root of 7. Okay, square root of 7, I can't really do anything about that. But now I need to finish solving for x. So I'm going to start by adding 1 to both sides. So that cancels out right there. So I'm left with 5x equals 1 plus or minus the square root of 7. And then I need to go ahead and divide both sides by 5. So I'll divide both sides by 5. That cancels out, so I get x equals 1 plus or minus the square root of 7 all over 5. Okay, and once again, I'll just leave it like that. It's possible you might have to write it out twice, one with plus, one with minus, but this is for shorthand right here. Okay, so we'll look at one more here. Okay, so I'm going to start by square rooting both sides, plus, minus. So that'll leave me with 3x minus 4 equals plus or minus the square root of 8. Well, what I can do here is 8 can actually get split here. I can break that up into a 4 times 2. Okay, so we haven't really seen this yet, but I can break this apart into 4 and 2, and then 4 is a perfect square, so I'm going to go ahead and square root that. So we have 3x minus 4 equals plus or minus 2, and then I still have a square root of 2. Okay, so I still have that right there. Okay, so now what we'll do is we'll go ahead and add 4 to both sides. So now we have 3x equals 4 plus or minus 2 square roots of 2. And then the last thing we'll do is divide by 3. And I'll put my answer up here. So x is equal to 4 plus or minus the square root of 2 over 2, all divided by 3. Now, in this case, it doesn't simplify, but as we move forward, we might run into some cases where we end up with an answer similar to this, and there can be a reduction made. But right here, this is it. There's nothing else we can do.